All right, let's go ahead and look at the questions from checkpoint number 3. So for question 1, we're looking at this function here. So let's just take it piece by piece. First, I want to find an expression for the derivative of this. So the last module we used the limit definition of the derivative to find these. Kind of getting away from these, we can use these kind of shortcut rules we have now. But if I want to find the derivative, I can use the power rule. So for part A, that's what I'll do. So f prime of x is going to be equal to, and then we'll take these terms one at a time. The derivative of 3x cubed will be, well, what do we do when we take a derivative? So if I want to find the derivative of x cubed, I'm going to bring down that power of 3 and multiply. And then I'll multiply, and then instead of the exponent being 3, I'm going to reduce it by 1, and that gives me a squared. The thing that I have to be careful of is that this was multiplied by 3, so I want to go ahead and respect that. And the same kind of thing for the next term. Derivative of x squared would be 2x. We have 2 times that because our coefficient of x squared is 2, or negative 2 actually in this case. What's the derivative of negative 5x? That'll be negative 5. And what's our derivative of 10? That's a constant. The derivative of any constant is going to be 0. So let's go ahead and clean this up, and we get what? 9x squared minus 4x minus 5. So that's our derivative. Part B, find the value of f prime of negative 1. So I found f prime, which is, the name we give to the derivative of f. So then what's f prime of negative 1? F prime of negative 1 will just come from us evaluating that function f prime when x is equal to negative 1. So what do we get when we do this? 9 times, negative 1 squared is 1, so 9. Negative 4 times negative 1 is 4 minus 5. So 9 plus 4 plus 5, that'll equal 8. So other part of the question asks, what does that say? So we're going to talk a lot about this. What does the derivative of a function tell you about that function? The derivative is this idea of an instantaneous rate of change. So basically, at an x value of negative 1, this function, which if you graph it, you'll see that it's a curve everywhere. There are no straight lines that make it up. But at each point on that curve, you can talk about a slope of this function at a single point. So for years, you're talking about slope as this thing that you need 2 points to calculate. Now we just need 1 point. So basically, the slope of this curve where x equals negative 1 is 8, or the slope of a tangent line. If you were to draw a line at the curve at that point, it would touch the curve exactly once at the point where x is equal to negative 1, and that line would have a slope of 8. All right, moving on. Find the equation of the line tangent to f at x equals 1. And we want to write our answer in this form, y equals mx plus b. So what information do we have here? Well, one of the things that a derivative tells us is about the slope of the tangent line. So I can already drop in 8 for m. I know the slope of this line, this tangent line, is going to be 8. So, and that comes directly from the derivative. So now how do I get the rest of the information? So I know what x is. I want to find the equation of this tangent line at x equals negative 1. So I have that x value. How do I find the y value? Well, the y value is going to come directly from not f prime, but f. So f of negative 1 will be equal to 3 times negative 1 cubed minus 2 times negative 1 squared minus 5 times negative 1 plus 10. So this is equal to negative 3 minus 2 plus 5 plus 10. This all comes out to be 10. So now I have a y value, I have the slope, and I have x. I can put all these things together and calculate b. So 10 is equal to 8 times negative 1 plus b. So 8 times negative 1 is negative 8. If I add 8 to both sides, I get that b is equal to 18, which means my full equation here is y equals 8x plus 18. And finally, part D, there are two values at x where the tangent to the graph is horizontal. So what does it mean? So tangent to the graph, basically the line is going to be horizontal. If the line is horizontal, what is the slope of that line? The slope is going to be 0. So basically, if you unpack what this question is asking, what it's saying is this: if I set the derivative equal to 0, basically I'm looking for the x values that make this true. So what's my derivative? That's 9x squared minus 4x minus 5. I'm going to set that equal to 0. So I have a quadratic. It's equal to 0. Lots of ways to solve quadratics. I'll go ahead and factor. 9 times negative 5 is equal to negative 45. What are some numbers? What are two numbers that multiply together to give me negative 45, but add together to give me negative 4? I think that'll be positive 5 and negative 9. So let me rewrite this. 9x squared minus 9x plus 5x minus 5. And again, this is only quadratic formula. There's lots of ways to solve a quadratic. So what's in common between 9x squared and negative 9x? I'm going to factor the 9x and I get x minus 1. Then the other two terms, 5x and 5, I think those I can factor a 5 out and I get x minus 1. And then finally I have 9x plus 5 times x minus 1 equals 0. So basically I have two factors when multiplied together equaling 0. So because of that, I can set each one equal to 0. So 9x plus 5 equals 0, and x minus 1 equals 0. If I solve the top one, I should get x equals negative 5/9. And the lower one, that should give me x equals 1. So these are the two places on this graph, and you can confirm if you graph this this function f, basically at those points, you're going to see that if you were to draw a tangent line, it would be horizontal. All right, moving on to question 2. So another function here. This function, I'm telling you, is a function that gives you the distance that a particle has traveled as a function of time. So I want to find the speed of this particle. So if I'm giving you a distance equation or distance function, how do I find speed? The speed is going to come from, I mean, how are speed and distance related? Speed is the name we give to the instantaneous rate of change of distance over time. So unpacking it that way, I know that basically what I'm looking for is this. I want to find the derivative of this function x. So what's x prime of t? So I can apply the power rule again. The derivative of 1/2 t squared will be equal to 1/2 of 2t. And then the next term, this derivative will be equal to 1/30th times 3t squared. And if I clean this up, what do I get? I get t plus 1/10 t squared. So this is my derivative, but I was asked to find the derivative at a specific value of time. So now, what is x prime of 10? X prime of 10 will be equal to 10 plus 1/10 times 10 squared. So 10 plus 1/10 of 100, that'll be 10 plus 10, which is 20. We should give the units here. That should be in meters per second. And then part B, explain why the particle will never come to a stop. So there's a lot of ways to do this, but let me write down the derivative again. X prime of t is equal to t plus 1/10 t squared. So let's first think about it this way. What would it mean for the derivative for the particle to come to a stop? If the particle stopped, that means that its distance would stop increasing. This distance would stop changing. So basically the instantaneous rate of change of this function x would be 0. So let's try to solve this equation. Where is this going to be equal to 0? So I'm going to try to factor out a t. I get 1 plus 1/10 t equals 0. Just like the last problem, I'm going to split these up. So I get these two equations, t equals 0 and 1 plus 1/10 t equals 0. This one's already kind of solved for us. This other one, if I start, doing the algebra, I get what? Time is equal to -10. But we don't really care about that because basically we're starting our time at time equals 0 seconds. This time of -10 is meaningless. Also, we do have time equals 0 seconds, but we know the particle is moving everywhere from then after, or at every time after this. So the particle is never going to come to rest again. All right, moving on to question 3. So one big idea we talked about applying, or one way we can apply this idea of a derivative is through marginal cost. So the function I'm giving you here is this C of t. C stands for the total cost of making, T fuel tanks. So T is the number of fuel tanks I'm producing in a week, and C of T is the dollar, like the cost, the total cost of doing that. So I got a few questions to answer. What is the total cost of producing 500 tanks? So the way I'm going to find that, the function I gave you is the total cost function. So for this one, I'm going to evaluate this function at a value of 500. So I hope it's okay with you that I calculated these beforehand, but I will show you exactly what functions you need to evaluate and where. But when I plug in 500 for t in my original function, I get a value of $42,500. So that's how much it cost me to produce 500 of these fuel tanks. B, what is the average cost of producing 500 tanks? So how do you find the average cost? So in general, the average cost, or, I think C with this over bar on it is kind of how we find these. If I want to find the average cost of something, I got to find the total cost and then divide that total cost by the number of objects that I produced in this case. So in this case, I want C of 500 over 500. And I know the total cost because I just found it. That's $42,500. And if I divide that by 500 units, I get an average cost of $85. So when I make 500 of these things, each one on average costs $85 to make. All right, next thing I'm asking you about is the marginal cost. So the marginal cost is the idea that does require a derivative. So let's find that derivative. So again, we're going to use the power rule. So C prime of t is equal to, what's the derivative of 10,000? So 10,000 is a constant, so its derivative is 0. The derivative of 90t is going to be 90. And how about the derivative of negative 0.05 t squared? So that's negative 0.05 times the derivative of t squared, which is 2t. So this comes out to be 90 minus 0.1 t. So that's my derivative. And the marginal cost of producing, so basically, what does a marginal cost tell you? If I evaluate this marginal cost function at, t equals 500, then basically what this approximates for me, or what this gives me a good estimate for, is the cost of producing the 501st fuel tank. So if I plug in 500 to the marginal cost function that I just found, that comes out to be 90 minus 50, or $40. Part D is a little bit different, or I mean, the way we're going to find it is very different, but instead of the marginal cost of producing the 500 first tank, I want the exact cost. The hint I'm giving you is that the answer to this question does not require a derivative. So how do I find the exact cost of producing the 500 first tank? So what does this function do? This function does not tell me. All this function can do is, when I plug in T, it tells me how to calculate the value or the cost of producing all T of those tanks. So basically what I have to do here is I have to find the total cost of producing 501 tanks and subtract from that the total cost of producing 500 tanks. So this will get, basically that difference is going to give me the exact value or the exact cost of that 500 first one. So this is what I'm looking for. And I will tell you that, so the C of 500 we already found. We saw that that is 42,500. And actually I did not write down the intermediate steps in my notes here, but I will tell you this. If you evaluate this function at T equals 501, and then subtract 42,500 from that, because that's what C of 500 is, the value we get is very, very close to what the marginal cost estimated, but it's $39.95. All right, that's all for checkpoint 3.